Okay, so I've got here my two functions, and I'm trying to find the area between them. Now my picture is not very good, but these two areas are supposed to be the same right here. So this is actually also symmetric, just like the one we just did. So we need to find our intersection point. So we set x square root of 1 minus x squared equal to 1/2 x. Okay, so to solve this one, we can divide both sides by x, but not before counting x as an intersection point. So we say that x equals to 0. I'll just write it down right here on the graph. We can see it pretty clearly. But x equals 0 is an intersection point, and so then we can divide both sides by it. So then we would get square root of 1 minus x squared is equal to 1/2. So then to get rid of the square root, you can square both sides. So then you get 1 minus x squared equals to 1/4. And might as well just get rid of the fraction. So if you multiply both sides by 4, you would get 4 minus 4x squared is equal to 1. Okay, so then we get 4x squared is equal to 3. And so x is equal to plus or minus square root of 3 over 2. Okay, now so that's what these values are. This is positive root 3 over 2 and negative root 3 over 2. But again, they're symmetric. So why do both when you can just do from 0 to square root of 3 over 2? And then we can do top minus bottom on that one, which would mean that we would have x square root of 1 minus x squared minus 1/2 x dx. Now this one is not super easy. It's got a little bit of work for it, so let's get right to it. So why don't I, instead of doing it as one whole integral, because in this section we're going to have to use integration by substitution. So I'm going to break this up into the integral from 0 to root 3 over 2 of x square root of 1 minus x squared, and then minus the integral from 0 to root 3 over 2 of 1/2 x dx. Okay, so let's work on this one first, because this one's a little harder. So notice that we have to use integration by substitution. So we have to let u be 1 minus x squared, and then du is going to be negative 2x dx. So that means that we need to put in a negative 2 here, and then a negative 1/2 on the outside. Okay, so if I do that, then I would get the integral. I'm going to change the limits of integration, but I'll wait for a second. So minus 1/2 the integral of these right here, negative 2x dx. Those two give me du, and then square root of right here, this is u. So this is going to be u to the 1/2 instead of square root of u. Okay, now the limits of integration. So this is what u is equal to. Now when x is equal to 0, u is equal to 1 minus 0, or 1. And then when x is equal to root 3 over 2, I get 1 minus root 3 over 2 squared, which is just 3/4. Well, that's 3/4, but then 1 minus 3/4 is 1/4. Okay, so then this is equal to, we use the fundamental theorem, so we get minus 1/2 times u to the 3/2, and then times 2/3. So these 2's are going to go away, and then I'm going to evaluate from 1 to 1/4. Okay, so then this is equal to minus 1/3, 1/4 to the 3/2, and then minus the negative, so this is going to be plus. When I plug in 1, I just get the same thing, so this is going to be plus 1/3. And that's equal to positive 7/24. Okay, so that's what I get for this integral right here. Okay, now let's do this, the other one. So this one is much easier, of course. So here I get, when I do this one, I get, the integral from 0 to √3/2 of x over 2 dx. So get the antiderivative, I get x squared over 4, and I'm going to evaluate from 0 to √3/2. Okay, so if I plug in √3/2, I get √3/2 squared, that's 3/4, and then over 4, well, that's going to be 3/16, and then minus 0. And so then my answer, my result of that area is going to be 7/24, which is this one right here in the red, minus, because there's this negative, 3/16, which is equal to 5/48. Okay, but that's not exactly right, because remember that was just from 0 to √3/2. So what we just found was that first half, and so the total area would be twice 5/48, or in other words 5/24. And so that's the area.